Welcome. In this lesson, we'll build a practical, no-math mental model of how modern AI actually works. You won't learn to code a model, but you'll be able to reason about AI products with confidence, understanding what these systems can do, where they fail, and why. Start with the core shift. Traditional software is rules written by humans, predictable and auditable, but unable to handle fuzzy problems like recognizing a cat in a photo. Machine learning flips this. Instead of writing rules, you show thousands of examples and let the system infer the pattern. The result is a learned model. The big consequence: AI behaves probabilistically, not deterministically. Neural networks are stacks of simple math units connected by weighted links. Training is just guessing, measuring how wrong the guess was, and nudging the weights to do better, millions of times. Picture tuning thousands of knobs until outputs match the examples. Deep learning means many layers of those knobs. And remember, the model only knows what it's seen, so biased or poor data produces biased or poor results. Large language models do one core thing: predict the next chunk of text, called a token, given everything so far. Repeat that and you get full answers. Because they learn statistical patterns of language, they're excellent at producing fluent, plausible text. But they output what's likely, not what's verified, which is exactly why they hallucinate confident but wrong answers. A few terms you'll use daily. Tokens are the pieces text is split into. Cost and length limits are measured in tokens. The context window is how much text the model can see at once, like working memory. The prompt is your steering input. And temperature controls how random or creative versus consistent the output is. Knowing these lets you talk precisely with your engineering team. 3 processes to keep straight. Training is the massive, costly process of learning weights, done by big labs. Fine-tuning adapts an existing model to your narrower task, cheaper but still an investment. Inference is running the model to answer what your users trigger and what you pay for every time. Most AI features just ride on inference via an API, and a bigger, smarter model means higher latency and cost. AI shines on fuzzy, pattern-rich tasks: summarizing, classifying, drafting, extracting, especially high-volume work where good enough plus human review is fine. It struggles where you need guaranteed correctness without oversight, where data is scarce or biased, or where the law demands strict determinism and explainability. Matching the tool to the task is a core PM judgment call. Plan for failure from day one. Hallucination is fluent falsehood. Mitigate with grounding, citations, and humans in the loop. Bias reflects training data, so test across segments. Models go stale because their knowledge has a cutoff. And non-determinism means the same input can produce different outputs, which complicates testing and trust. Your guardrails are the product. Here's the mental model to carry with you. Treat an LLM like a brilliant, fast, well-read intern who is occasionally confidently wrong and almost never admits uncertainty. Your job as a PM is to build the context, guardrails, and review loops that turn that intern into something reliably useful. That's how you ship AI products responsibly.